In this video, we will build an application that will help in removing background from human videos using deep learning. So, hello friends, welcome to this video. This is Nikhil Tomar and you are watching Idiot Developer. Make sure to subscribe the channel and hit that bell icon. Now let's move on to the task, that is background removal from videos. So first of all, let me show you a few video samples which we will use in this video. So here is the first video sample. Here you can see this female dancing, and at the end, while our task is completed, what we'll do, we'll remove background from this video and this female would only be left. So it's a kind of, you can say, background would be replaced black and the human would be there. And this is the second video. So we have videos from different perspective and different environment, you can say, and they are not static. The human or the female is moving, you can see. So this is the video input. Now let's move on to the coding part. So let me also show you the weight file, then you will question. So this is the weight file. I have already trained a model on human image segmentation using a custom architecture which contain a pre-trained ResNet 50, some dilated convolution block and few decoder block. To learn more about that project or that video, please check the I button or the description. You can get that video. You can watch that video after this. But if you are interested in removing background, then this video is enough. I'll give you the link of the code in the description. From there you can access all the files, and also the weight file would be accessible. So don't worry, I'll also provide the weight file along with the code. Now let's start with the coding part. So first of all, we are going to import all the libraries. First of all, we have import the OS libraries because we are dealing with videos. So we need to access from different folders, and you may be using this project on Windows. So I'm using OS library to make sure that OS dependability is not there. So the code would work on Ubuntu, Mac or Windows environment. Now this is one of the simple line which I write, and this line help to get rid of all the messages or the views, not the views, the messages which come when you load the TensorFlow. It shows you GPU or any warnings, etc. Next we have imported is NumPy. So NumPy is used for numerical calculation, as we are dealing with videos, and videos are represented as frame, and each frame is represented as a NumPy array. Next we have OpenCV. So OpenCV would help us in reading the video, then frame, then resizing and all the other stuff. Next we have this globe. So globe would help us in extracting all the video parts. Then this is TQDM, and I don't think we require this. We can remove this later on. And finally, this is the TensorFlow, the framework which we will use for this application. So our entire thing would be around TensorFlow because that is the main library which we'll use. Now let's define some global parameters. You already know we have trained a semantic segmentation model to build this application, and that model takes the input size as 512 by 512. That is the height and width which we have specified here. Next, we are going to create a function that would help us in building folders or directories. So this is that function, that is create_dir. It takes your path, then it check if that path exists or not, and if that path not exist, here you can see, if not, os.path.exist, then path, then it's going to create that folder. That's it. Now we'll move on to the main line. Okay, this is the main line, refers to this line from where the execution of the program begins. So first of all, we are going to seed the environment. Okay, so we have seed the environment. This is done to make sure we have reproducibility, because if you have a basic knowledge about the deep neural networks, they are randomly initialized. So randomness is at some part is there in it. So to make sure the randomness is always seeded first. This is to make sure you have reproducibility, so that, how can I say, so that you have same randomness every time. That is what I means to say. Now let's create a folder to store our videos where background has been removed. So this is the folder where we would save them, that is video/output, and inside this folder we are going to save our processed videos. Next we are going to load the model. So let me write it, loading model. So we're going to say model equals to tf dot keras dot models, then load model, and inside it you need to provide the path to the weight file. So files slash model.h5. Now what we'll do, we'll print the summary of this model file so that we know whether this model is loaded or not. So let me, what is the name of the file? Is video. Okay, video.py. Let's wait. Okay, so you can see we have reached this end part, and here you can see, if you see the output, it provide you 4 different binary masks, but we are going to use the last one. Okay, out of the 4th one would be the final mask. Now we have successfully loaded the model. So let us move back to the code. So first of all, we need the video path. Okay, let me write here video path. So let's have a variable called video name. So video name, let's say video 1. Okay, now we need a video path. So video path is this, the video path. Okay, let me put some space here. So this is the video path, video input, and the video name dot mp4. And if you see, all the input videos are in mp4 format. It's up to you, you can directly specify the full name here, but I'm doing this because we also need to save the video, so we need a name. That is why I have a separate variable called video underscore name, so that we can use this later on. Now we need to read the first frame from the video, reading frames, so that we can get the height and width of the video. So we're going to say vs is equals to cv2 dot video capture. Then here we'll provide the video path. Fine. Now underscore and then frame. I'll later on tell you what this underscore basically means, what it give you. But for now, just focus on this part. Now we just need the frame to get the height and width. So we'll capture the height and width from here, and we're going to say frame dot shape. Then now we have the height and width from the input video. Now we're going to release the video file which we have captured. So done. Now we're going to write some part of the code, and here it is. So this is basically the video encoder, I think. Okay, this would help us in saving the video. Each frame we're going to save. Next we have this out variable. Inside this basically is a variable where we are going to write our frame, and this function video writer would help us to save it as a complete video in this folder, that is video outputs. And here you can see I have used this video name, and the extension for the video would be .avi, and this is 4cc which we have specified above, and these are the number of frames, the fps. We want 30 fps. The width and height of the frame which we're going to write, and the last one is set to be true. Now what we do, we're going to say cap. We're going to again capture the video, so we can simply copy it from here. Now we're going to have a while loop, that is an infinite while loop. So this is while true, so infinite while loop. So we're going to say ret frame equals to cap dot read. Now if you see, these both statements are nearly same, just that in the above one we have underscore because this is not required, but here it is required. So this ret, if it is false, this means no frame is left. You can now break the loop. Okay, if you have some frame, it would be true. If frames are not there, it would be false. So this way we break the loop. If ret equals to false. Then we're going to say cap dot release and out dot release. Done. Now we're going to break the loop. Simple. So we have a code to break the loop also, because this loop is an infinite loop. If you see while true, so this condition is done. Now if we have frame, now we'll work on the processing part. We will receive the frame, process it somehow. So first of all, we're gonna have height and width. Okay, it should be height comma from the frame. Now what we're gonna do, we're gonna save a copy of this original frame and another variable. Now we're gonna say frame. Now we're going to resize the frame. So while resizing, provide first the width, then the height. You see, these width and height we have already specified at the top. See this part? We have resized the frame. Now we're going to expand its dimension on the last axis, and then we are going to normalize it like this. So here if I show you how it would be like height by width, and these are the number of channels because it's an RGB. Now we expand its dimension. It would be like 1 by height by width, number of channels. Because deep learning models, that is the model which we're going to use here, usually take input in the form of batches, but here we have only one image or one frame at a time. So what it does, what we do, we create a batch which contain only one frame. Maybe you can make it more efficient somehow. You can give it more than one frame. That would be more efficient. But for now, we are just giving one frame at a time. So we now in the next line we normalize the frame by dividing it with 255. Now understand this concept of normalizing and dividing. Why dividing with 255? So we divide it by 255 because this is the maximum pixel value. So in this way we normalize all the pixel value in the range of 0 and 1. So this is done. Now we're going to make prediction. Mask that would contain the output, the predicted mask, model dot predict. If we're going to give the input frame, and here we're going to say verbose equals to 0. Okay, now I'll put a break. Now we'll analyze the mask. I'll print its shape. Now what we're going to do, we're going to run the code and see the shape of the mask. So we need to wait. Okay, so you can see the output is also in a batch of 1. Okay, then we're going to see the output mask height and width, then number of channels. Here are 4. So what we're going to do, first we're going to say 0 because it's a list. So we extract this. Now we have shape that is 512 by 512 by 4. Now we need to extract the last mask. Now just see carefully because even I got confused initially with extracting things like this. So first is height, we don't need to touch it. Then width, we don't need to touch it. We just need to work with this last one. So what we're going to say, this colon symbol, then comma. This is for height. We don't want to touch height. It should be as it is. Then width, then -1. Okay, so this is fine. Now if I'll show you the shape of the mask. It would be, I think, 512 by 512, either 1 or it should be like 512 by 512. Okay, you can see this is the shape of the mask, 512 by 512. Now if I save this mask, let's okay, it should be, I am right, mask.png mask, and I should multiply it with 255 because the output of the mask are the values from 0 to 1. So you cannot view 0 to 1, but if you multiply them with 255, they would come in the range of 0 and 255. Now let's run it again and see that mask. Okay, so it's done. Now I'll show you the mask. You see, this is the mask. and its size is 512 by 512. Now we are going to resize this mask. Okay, so I'm going to remove this line. So what we're going to do, first of all, we resize this mask to original frame height and width to match this, the height and width of original frame, because we are not going to resize the frame when we save the video. We're going to resize or increase the height and width of the predicted mask to into the input frame. Next, we convert it to float 32 and we expand its dimension to the last axis. Now if you know, here the size is height by width, this provided small this. Now here we convert to float 32, it remains the same. Now here it would be like height by width by 1. This is how it became. Now here we need to do some processing. So first of all, I have a variable called photo mask equals to mask. Done. Now we have background mask. So background mask would be np.abs. It should be absolute value 1 minus mask. So this is the photo mask. This is foreground mask. That what you have seen here, kind of similar to this. Okay, so let me just save both these value for you, and I'll show you how they look. So first would be photo. Okay, let me just directly copy this photo mask.png, and again should be multiplied with 255. Okay, now I'm going to copy it. Then we're going to say background mask. Okay, now we're going to run the program again, and this time we have two masks. First is a foreground mask, second is a background mask. So this is the photo mask. So you can see now the frame is resized, not the frame, the mask is resized. This is the foreground or the main object mask. Second is this background mask, if you see. So with the help of these two masks, we can extract the required thing from our video frame. So this is how it works. So let me remove these two lines also. These are unnecessary. Now we have masked frame. What we can do, original frame multiply photo mask. Now if you see, the value of photo mask is in the range of 0 and 1. Now we don't multiply it with 255 here. Original frame pixel value are from 0 to 255. So we multiply it with this. Now just view it as a multiplicative problem. So if the value in the photo mask is near to 0, or it's black, so it would multiply with this original mask and it would become 0. If anything is greater than 1, let's note the greater than 1, greater than 0, if it's 0.1, so it's gonna remove the mask with that specific intensity. You can also apply thresholding here like 0.5, that would convert all the values between 0 and 1. But here I don't do that. I just like that soft thing, the soft edges of the which is provided by this logits, you can say, without the threshold applied. So we have this masked frame. So I can save it for you here. You can say masked frame.png masked frame. Now we don't need to multiply it with 255. Okay, so this is done. Okay, so if you see, this is the masked frame where we have removed the background and we have just extracted the main object from this frame. Now let's imagine if I apply threshold. Let's say I apply threshold here. Say I apply it here. Mask, not here. Let's apply it after resize. Mask equals to mask greater than or equals to, say, 0.5. Let me run this again. Now I'll show you the difference. Okay, now if you see, the edges are more crisp. Okay, so this is what happened when you apply the threshold. But if you remove the threshold, the edges would be soft and they would make better sense. So that is why I don't apply thresholding in this case. Now let's say you wanna have a custom background. Okay, so let's do some code part here so that we can have a custom color background. So first of all, we have this background mask here. So the shape of background mask, if you remember, would be height by width by 1. So here we concatenate it 3 times on the last axis. So how it would become? It would become height by width by 3. It would have same number of channel as in your input frame. Now we need a background mask, not the background mask, a background color. So this is the RGB code for your background. For now it is 000, which means black. So you can apply 255, whether it would be red or blue. Let's say how it works. Even I may be confused. So you can say final frame equals to masked frame plus background mask. Okay, now final frame equals to final frame dot s type. We're going to change this data type to unsigned integer 8. Okay, now it's fine. Now let me save this for you. So this is final frame dot png. It's done. Now we need to save it and we're going to run the code. Okay, so you can see this is the final frame. So you can see now we have a red background. So this means the code works like this. It should be BGR. Okay, not RGB, it's BGR. Let's say if we provide now how it would be changed. So let us, okay, if you see, we have changed the background accordingly. So if you see, the edges are a bit not good here because the model is not trained that good. So you can train it more efficiently with better architecture and you will get better performance. But what I will say, this is also good, but if you apply thresholding, it would be worse in this case. Okay, so don't apply thresholding. These soft edges looks much better than thresholding. Now we are done with this part. Now what we need to do, we need to simply write this file into this out video file. So what we need to do, we need to remove this break line from here. We need to say out dot write final frame. Now this is done. Now at the end we'll say completed, so that we know the task is done. So let me run this code. And now I'm assuming we're gonna have a file. This is videos, is the output. And if you see, we have our file here. So we know things are going fine. And if you see, its size is increasing. See, now if I play it, you may get something. So you see, because some part of it is saved. So you can see some part. So this is still not complete. So it's gonna take some time. So let's wait for that time. Okay. I think it would be done pretty fast, I'm assuming. So maybe to make it more efficient, you can use multi-threading, or because I provide only one frame at a time. If you see input to the model, you can provide more than one frame at a time. Maybe that would make it more efficient. You can improve this pipeline. That's up to you. That can be a task to you. Okay, you can make it more efficient. But for now, we're gonna move on the simple way. So it's taking a bit time because it's frame by frame. If you see, it's read each frame, then it's save. So what I'll do, I'll pause the video here and I'm going to continue when it's done. So the video is now done. Now I'll show you how it look. If you see, this is how it look with a specific background. Now you even have the control of the background. If you are more smart, you can put a static image behind it, or you can put video frames. Like, it's up to you how you're going to use this code and make it more efficient. Or if you not, I'll upload more videos in the future where we'll have custom background, or we'll have some frame of a video. We can put some frames to the video so that even the background is moving and the object is also moving. Okay, so let me show you other two examples. So here we have black background. You can see how efficient it is, but the drawback here is that at the edges part where we need fine quality, it's not working there. And one more thing, because the model is trained for static images, not for frames, because frames have temporal dependencies. So that's why it sometime it may have difference between two frame, because but that is fast, so you don't get it. But if you save individual frames, then you will see it. So within some frames, it gonna lost the good information. But when you play test videos, it's fine. So what I would say is just train the model more with better architecture on more epochs with better data augmentation, because I think I haven't applied the data augmentation also. You can apply that part, make the model more efficient. But that's all for this video. I hope you have enjoyed and learned something new. Maybe you can use it in your project or somewhere else. Okay, so if you have enjoyed this video, please make sure to subscribe the channel, like this video and share it with your friend. Now at the end, I want to say thank you and a happy new year.